First thing we want to look at in this section is called the discriminant, and it's the expression that's under that square root symbol in the quadratic formula. So here, let's find the discriminant for this quadratic equation right here. First thing I do is put it into standard form. Now the discriminant, which I'll call d, is simply b squared minus 4ac. So for this equation right here, it's b squared, which is 16, minus 4 times 3 times 2. So I get 16, subtract 4 times 3 is 12, times 2 is 24. 16 subtract 24 is going to be negative 8. When the discriminant comes out to be a negative number like this, it means that we're going to have complex solutions to my original quadratic equation. So this implies two complex solutions involving the number I. So your discriminant in the quadratic formula tells you the kind and the number of solutions that you're going to get to a quadratic equation. And there's some circumstances in which that's the only important thing. You don't need to find the actual solutions themselves. So this can be a little shortcut if all you want to know is what kind of solutions you have. The next thing we want to do is go build some equations from their solutions. So the instructions say find an equation if the solutions are x equal 5 and x equal 2. Well, let's just work backwards in our solution process. If x is equal to 5, that means that x minus 5 is equal to 0. And if x is equal to 2, that means that x minus 2 is equal to 0. Well, if x minus 5 is 0 and x minus 2 is equal to 0, then certainly x minus 5 times x minus 2 is also equal to 0. So if I have two numbers that are equal to 0 and I multiply them, I still get 0. Well, this gives me an equation right here that has solutions of 5 and 2. I'll just simplify this by multiplying these out to see what it looks like sort of in standard form. X squared minus 7x plus 10 is equal to 0. So there's one equation that has solutions of x equal 5 and x equal 2. Now, any constant multiple of this equation also would have solutions of x equal 5 and x equal 2. For instance, 2x squared minus 14x plus 20 equal 2 times 0, which is 0, also has those solutions. So here's one equation, though, probably the simplest form equation that we can find that has these two numbers as solutions. Here's another problem. X equal negative 2/3, x equal 2/3, x equal 1. Well, if x is equal to negative 2/3, I'm going to multiply both sides by 3, and then I'm going to add 2 to both sides. So this means that 3x plus 2 is equal to 0. Here I'm going to multiply both sides by 3, and then I'm going to add negative 2 to both sides. I'll get 3x minus 2 is equal to 0. Here I'll just subtract 1 from each side, and I get x minus 1 equals 0. So in each case, what we do is go from the original solution to an equation that has 0 on one side. Now, if all three of these expressions are equal to 0, then so is their product. 3x plus 2 times 3x minus 2 times x minus 1 is also equal to 0. Let's see, I'll multiply these two out, and that'll give me 9x squared minus 4 times x minus 1 equals 0. I'll multiply both of these by x. I'll get 9x cubed minus 4x. I'll multiply them both by negative 1 minus 9x squared plus 4 equals 0. And let's see, in standard form, decreasing powers of the variable, 9x cubed minus 9x squared minus 4x plus 4 equals 0. So there's an equation that has these three numbers right here as solutions. So you can see we build equations from solutions in roughly the reverse order that we solved equations to get those solutions.